Okay, so far we've gone over foreign key constraints, but the other kind of relationship that I'd like to talk about and show you how to set up is a many-to-many relationship. So let's pull up our ERD and go down to this final state. So for this example, let's say we want to have an activity table, and these can be things like hiking, fishing, camping, and we want state forests to kind of have a way to list which activities are allowed there. So any state forest could have multiple activities, and multiple state forests could offer the same activity. So that's a many-to-many relationship. And the way they're represented in databases is this relationship table. And what it consists of is every row has a pair of foreign keys, one of which points back to, in our situation, state forest ID. The other one will point back to activity ID. And the third row is the primary key. And what this is a composite key between state forest ID and activity ID. So really, it's just a constraint. There will be no column called state forest activity p key. And all this is doing is it's making sure that you can't have 5 of the same state forest with the same activity. All right, so let's go ahead and go over how to create that in Clojure. So, as usual, we want to use our JExecute form against our database, and for the SQL, we are going to create table DDL. The table name is activity, and then let's see, activity ID is serial value. It is a primary key. And then the activity name is varchar. And let's just say it's 64, because I think they're going to be pretty short. I haven't seen a long one yet, at least. Boom, boom. All right, so we should be good. Okay, all right, so now we have our activity table created. So let's go ahead and add some activities. So I went ahead and looked up what activities are available at Geneva State Forest in Alabama, and we will add those now. So the activities are, the first one, activity field is hunting. Let's just copy this. Okay, and there are 5 of these, 3, 4, 5. All right, so we have hunting, we have fishing, we have trail riding, we have hiking, and we have primitive camping. Primitive camping. All right, so now we have the activity table populated. So the next thing we're going to do is create the relationship table. This guy. Okay. So this will be a little bit different than what we've seen so far, but I think it'll make sense, especially if you have a background working with SQL. It'll make sense to you. Okay, so against our database, we want to create a new table DDL and execute it. The new table's name is state forest activity. Okay. Oops. All right. So for this, we want state forest ID to be the foreign key, and we are going to references state forest, and on update cascade, and on delete cascade. All right, so let's copy that because it's pretty darn long. Go back over here, drop down, paste it, and let's see, this is going to be activity ID references activity. And again, we want on update cascade and on delete cascade. Then this is the line that's kind of different. Like I said, so this is a composite primary key, but really it's just a constraint. We're not going to have a column for this. So let's see. So we want constraint, and we want to call this, let's just call it state forest activity p key. State forest activity p key. Yep. And then let's see, we want this to be the primary key, and we want it to be composed of state, forest, ID, and activity. ID, that closes that, that closes that, that closes. Okay, all right, there we go. So we have our new state forest activity table. So the next thing we need to do is create association. So we could manually go through and query get the primary key ID values for a state forest and the primary key for an activity, and then just do an insert where we pass both values in, but that's kind of a pain in the butt. And because this is a relatively common operation, I'm just going to go ahead and create a couple convenience functions to do this. So the first thing we need is ID for state forest. Now this function here is basically the same as what we did when we did ID for state. And so in the real application, what I would probably do is create a more generic function that can basically retrieve the ID for any record. But for what I'm doing now, just these quick tests, I don't mind a little bit of duplication of code. So I'm just going to create individual functions for the different tables. All right, so state forest equals, so select state forest ID from state forest, where state forest equals, and then we want to, let me just look at, okay, so the state forests are proper nouns. So this is where we're going to use the capitalize function. I'm going to capitalize the name. So we only want the ID back. So row function to be state forest ID. And then again, we just want the number. We don't want it wrapped in sequence. So result set sequence, I'm sorry, result set function, and we want to just grab the very first element. And that should extract it. Okay, so now if I do, let's see, ID for state forest, and let's pass in, well, let's try lowercase, since it should capitalize it for us, Geneva. All right. And Geneva is ID 15, which is good. Okay, I'm going to create another specific function or ID for activity, which is, again, sort of duplicate, but I don't care. So basically the exact same thing. Only this time, let's just grab this to here, I believe. Yeah. So we'll drop this down, paste it in. So we want this time to grab activity ID from activity where activity equals string.capitalize. And this one, these guys are all lowercase. For the final app, I would probably be making notes here while I'm doing this. And one of them would be to either standardize either all caps or all lower, then handle like capitalization for proper nouns, uppercasing and lowercasing, however I want to display it sort of in the application code or in the logic, the display logic. So that is something that, you know, you notice when you're doing these explorations, which is super helpful. All right, so where activity equals name, and then let's see, sort of row function I want to extract the activity ID, and again I want this. So that's that. So let's see, so if we want this ID for activity, and let's do caps fission or capitalized fission. Cool. All right, that works. Okay, so all right, so let's take a look at what our activity table looks like. So if we do jQuery db select everything from activity. Okay. So we have the activity ID, which is an integer, and then we have the activity, which is a string. All right. So when I'm adding these relationships, ideally what I'd like to be able to do is sort of specify the name of a state forest, then pass in a vector of activities that are allowed there. So the signature would be something along the lines of, let's just say load stuff, whatever. And then we would want to pass in the state forest name. So let's just say Geneva, and then we would want to pass in a string that's like hunting fishing. Okay, something like that. We want this to just run. Now to do that, we would need a map that represents any given activity like that, right? So hunting becomes the key that we match against from that parameter list, and then the value we insert would be the actual the ID value. All right, that may not have made sense, but just bear with me here for a second. I think it'll make a little bit more sense in a second. So this is what activity sends back to us, right? So I'm going to create a remapper function. Let's see, activity remapper. All right, so I'm going to pass in a map, and I am going to create a new hash map. And what I want to do is apply the keyword function to the activity, m. For the value, what we want to do is extract the activity ID of m. 2, 3. All right, so let's test that. So if we do activity mapper, and we're going to be iterating over this collection. So let's say, but let's grab one of these. So activity ID 1, activity hunting. Copy that, paste it in here. If I run this, it will blow up. Why? Activity mapper. Oh, because I spelled, oh God, too much Python. There we go. All right, so now we've got a key of hunting, and the value is the ID. So now we can use this to populate the relationship table. All right, so let's create our function now. So we'll do definition load. Instead of stuff, we'll call this load state forest activities. Right. Okay, so for parameters, what we want to pass in are state forest name and activities. All right, so first thing we want to do is we want to do a lookup and get the state forest ID. So we want ID for state forest, SF name. All right. Then the other local variable we want is activity map. Okay, so what this is basically this, only we want a single map that has all of these different key pairs. So it would look something like, colon hunting 1 space, colon fishing 2, etc. All in a single map though. We just want to apply a lookup to that map. All right, so that's going to look like for activity map. All right, so we're going to apply the merge, and we want to merge the result of query db select all from activity, and then we want to use the row function, and we want to use our activity remapper function that we just wrote. So that should be this. Okay, so that closes the let right there. So now we want to insert multi to our DB into state forest activity, and we want to map over the result set and create new hash maps where we have state forest ID being equal to SFID, our local variable. Let's see, hash map, state forest ID, and then let's just add a comma to keep this easier to read. So then activity ID would be equal to, all right, let's see, we want to run the keyword function against activity ID value from the activity map. And then we want to pass in all the available activities. Is that right? I think that's right. All right, so now let's see if it works or if it explodes. So load state forest activities, bang. All right, so into Geneva State Forest, we would like to load all of our activities because these are all the ones that were listed on the Forest Service website. There's probably other ones that I would be adding for, as I go through other state parks, I'd be adding different ones. But we can assume that these are going to be common, at least in Alabama. All right, so let's see. So we've got hunting, fishing, trail riding, hiking, primitive, camping. That should be all of it. There we go. So these are the records that have been inserted into our relationship table. So let's go ahead and query it. Well, we'll basically get this back, but just as a sanity check. So we'll do jQuery, db, and then what is it? Just the SQL. So that's select everything from state forest activity. Yep, there we go. Cool. Okay, so that's pretty good. The other really common thing we're going to want to do, obviously, is get stuff back out. And to do that, what I'd really like to do is have a convenience method where I can say query activities, and then just pass in, or maybe query activities for, and then say Geneva, and then get back a list of all the different activities. I don't want to have to get back the IDs and do a separate lookup and all that stuff every time I do this, because really this is pretty darn common. So let's go ahead and, all right, so what do we need to do here? So, all right, so similar to how we had the name for the state forest ID, we want to do something, we want the name for the activity ID. So if we do define name for activity ID, and then we're going to pass in, let's just say, I don't think ID is a keyword, probably that. So jQuery DB, and we want to select activity from activity where equals, and then the parameter is ID, and then we want to apply, we just want the activity name. So for the row function, we just want activity. All right, so that will do the lookup. Okay, let's test it. So now if we have an activity ID, let's say 2, this should give us fishing. Okay, cool. Yep, trail riding. All right, awesome. So, all right, so this last part's kind of weird. So the activity query needs to use the in SQL condition. And the way that works is that you pass a list of comma-separated values for the different IDs. So for our case, we'd have 1, 2, 3, 4, 5, or whatever comes back from the lookup in the relationship table. Now the problem is clojure.java.jdbc, it cannot infer the basic type that you're passing in if you try to do a parameterized value and just pass in an entire list. It can't do it. So you've got a couple different options. What I'm going to do here is I'm just going to do a string format to dynamically build my SQL string, my select statement. But in production, you might not want to do that. If there's a chance that the values that get formatted into this SQL command could be entered by a user or manipulated by a user, you don't want to do this, because then you run the risk of SQL injection attacks. For this situation, it's fine, because I don't anticipate this being something that people would be passing in. Typically, they'd be passing in a state forest name, and then the system would be generating the list of the different values that get formatted into the next selection string. But if you were in a situation where you ran the risk or thought you might be sort of formatting user-entered strings, then you would want to either make sure you're escaping the string properly so they can't inject SQL, or you need to actually go in and alter the underlying interface for I believe the query form itself, and extend it to cast the different clojure data types, the sequence data types and collection data types or whatever, to primitive data types that the JDBC understands. Anyway, don't worry too much about that. I'm just going to do it with this formatting, and if you have a situation where you're not concerned about SQL injection, this is fine. All right, so query activities, and we'll say for state forest. We will pass in SF name as the argument, and then let's see, so we need a local variable. All right, so the first thing we want to do is get all the activity IDs. And so that's jQuery.db, and we are going to, select activity ID from state forest activity, our relationship table, where state forest ID equals question mark, and then for this we want to run the ID for state forest function and pass in our state forest name argument, and then we would like to apply a row function there and just get back the activity ID. I'm going to zoom out a little bit so that's one line. All right, hopefully that's not too small for you. Okay, so we've got this, boom, boom. All right, so now our actual code, our query, jQuery.db, and we want to, so we're going to say select activity from the activity table, where the activity ID is inside, here's the replacement, and what we want to do is join, comma separate everything in the activity IDs. So 1, 2, 3. And then what we want to do is just extract the activity name. Activity. We've got 1, 1, 2, 3. All right. Okay, so let me go over kind of what this is doing. All right. So the activity IDs, we're running this query, we're selecting the activity ID from state forest activity where the state forest is equal to this parameter. So this should be fairly self-explanatory, but I'm going to run it just in case. So we're going to grab this form, and instead of a parameter here, what we're going to do is, since we're passing in the name, we can just, we'll just do it by hand here. Oops. Forest, oh, I'm sorry, forest ID. All right, so our forest would be, wait a second, oh God, SF name. Oh, ID for state forest name. So what was Geneva? Oh geez, let's see. All right, so 15 is the ID, okay. All right, so we'll go back here and just enter 15. Okay, so this is what we're getting back. So we're getting back this sequence that has the ID of all the different activities, right? You remember back up. Here we go. So activity ID 1, activity ID 2, which then relate to activity ID 1 is hunting, etc. So this is what activity IDs is equal. So activity IDs, this, okay? What this is going to do, so let's run this against our activity ID. So activity IDs, like we just said, is equal to 1, 2, 3, 4, 5. All right, so if I run that, I'm getting back this string of comma separated values. So what happens when this enters the string replacement is that it places this comma separated list of IDs inside these parentheses. So my SQL query just gets executed in here, and then we extract the activity, okay? So let me clear this stuff out so it's a little bit cleaner to look at. Okay, so let's go ahead and use it. So now if we do query activities for state forest, and let's pass in, we should be able to pass in lowercase. There we go. All right. So that's pretty much everything I wanted to go over in this video. I know it was fairly long, and as you can see, clojure.java.jdbc is pretty low level. We wrote a lot of SQL. There was very little abstraction on it, but in a way that's a strength. If you're familiar with SQL and you don't want to deal with learning a new DSL, it is very easy to get up to speed with this library. Now, if you're not comfortable with SQL, then a higher level abstraction would probably be preferable. And again, there's a number of other SQL libraries for Clojure that offer higher levels of abstraction. We're going to go over those in some of the other videos. But again, if you're comfortable with SQL, this is and understand the risk of SQL injection attacks, this is a great library. Or if you're building your own DSL, this is where you start. All right, so that about wraps it up. Thanks for sticking it out, and yeah, hit me up on Twitter or shoot me an email if you have any questions.